Hollow moon. It's likely that when you hear these two words together, the next words you'd think of would be conspiracy theory. That's not surprising, as it would be the bulk of the material you would find on the subject if you typed those words into your search engine. I want to assure you that I will not be referencing or even mentioning any conspiracies. I tend to think that if the data about our moon suggests that it may be hollow or perhaps porous on the inside like a sponge, that there may be natural reasons for this. To really crack open a mystery, we need to look very closely at all of the cold hard facts, the tangible evidence, all of the collected data, the scientific research, and the math. Lucky for us, we actually have some hard data about our moon, and more discoveries will soon be made as the world continues to make bold efforts to explore it. In this episode, we will take a deeper look at the available data for any clues about the interior of our mysterious satellite. We will also explore with greater detail the materials and the forces involved in the impact event that likely created our moon. We'll discover what may have played a very important role in this event, and how that may be the reason for our naturally hollow moon.
Scientists said, let's separate the lunar module and have it impact the moon just at the right distance away from this seismometer that they put there, and we'll measure how it vibrates, and that'll tell us what's going on in the center of the moon.
Traveling at almost 3,800 miles per hour, the used vehicle slams into the moon's surface, creating a 30-foot wide crater and a moonquake. The results recorded on the seismic sensors astonished NASA scientists.
When they saw them on the seismic record, it was ringing like a bell. It just wouldn't stop.
This, of course, set off a search to try to find an explanation for what this big difference between what we see on Earth, where the earthquakes only last for a few minutes, and on the moon, where they go on for hours and hours.
Scientists who were willing to think outside the box said, hey, that's hollow. We have a hollow moon. Once you go down the path of a hollow moon, everything is on the table.
So if the moon were hollow, what would that mean? Well, obviously it's not a naturally occurring phenomenon, so it's got to be artificial. Somebody put it there, someone built it.
That's no moon. It's a space station.
The idea that the moon could be an artificial space station, how difficult it is just to get our space station up. Can you imagine putting something the size of the moon in orbit? I don't think so. It has a bigger story.
Yes, it does have a bigger story. If the moon is indeed hollow, and this is a natural phenomenon, this should be a major clue in the story of how our moon was created. Still don't think it's possible that our moon could be hollow due to natural reasons? I can think of one. Before revealing my answer, I'm going to see if you can guess what I'm thinking about. I'll give you 3 clues. Ready? Here are the clues. This is a naturally occurring geological formation here on Earth. The most common types of these are made up of basaltic lavas, the same stuff that makes up our moon. This formation is hollow on the inside. Have you guessed? It's a geode. If the moon is actually a geode, this would suggest that certain conditions and materials would have to be present during the event that created our moon. Just what would be necessary for this event to occur? In order to get a better idea about how a geode moon could even be possible, we must first learn how geodes are naturally formed in the first place. Let's look closer at the facts about geodes and see if we can find more clues to this mystery.
As I'm sure you know, there are plenty of beautiful gemstones out there of varying shapes and sizes. But there's one category of stones that teaches us it's what's on the inside that counts, the geode. If you're a rock nerd, like me, your fascination with geology and gemology probably began with geodes. And of course you are, and of course it did. An unassuming stone with a hidden surprise inside, they're basically nature's wonder ball, but instead of mediocre candy, you'll find quartz crystals, agate, in some rarer cases, opal. But these amazing hidden gems don't just form overnight. It can actually take these glittery microchasms thousands, even millions of years to form. It all begins with the creation of a cavity within a rock formation, and there are a few ways that can occur. The most common way these spaces are formed is not by excessive consumption of candy, but by the water vapor and carbon dioxide that gets trapped inside streams of lava and magma. Since the CO2 and water vapor are both gaseous, they create spaces inside the molten rock that gets trapped as it cools. These spaces also form in underwater volcanic eruptions. The immediate contact between the ocean water and the super hot lava causes the outside layers of magma to cool much faster than the inside layers. The resulting pressure of the quickly cooled outside layer on the molten inside layer of the rock causes ruptures where the molten rock can leak out, leaving behind an empty shell of now solid igneous rock. A third and less violent way these spaces can occur is within sedimentary rock. Over an extreme time, layers of sediment are packed on top of each other, but not all the organic materials swept up in this process will turn into sedimentary rock. Occasionally, pieces of wood, coral, and other minerals can get trapped in the mix and may wither away after the sedimentary rock is formed around it, leaving behind a cozy little spot for crystals to grow. In all these cases, the resulting cavity may appear to be encased in a completely solid stone, but the outer shell is actually porous on a microscopic level, allowing groundwater or rainwater to seep into the rock, bringing a whole host of minerals along for the ride. The water is just passing through, but it leaves behind these minerals that, over time, begin to line the inner walls of the cavity. As these minerals settle down, they begin to stretch their proverbial legs and form all kinds of crystal shapes. Now, the formation inside the cavity varies depending on the type of rock. For instance, you're more likely to find quartz crystals inside of igneous or volcanic rock, and silica is more likely to form within a sedimentary rock. The gemology laymen and laywomen out there mostly associate geodes with quartz crystals of either the milky or translucent variety, or the deep purple amethyst. The two have the exact same molecular structure, but the iron impurities in the amethyst give it an amazing purple color that would have certainly made Prince swoon. She wore a raspberry beret, the kind you find in a secondhand store.
There have been many different theories throughout time about our moon and how it came to be Earth's companion satellite. One thing is sure, any theory that is valid has to weigh up to all of the data that we currently have, and any new information that may be revealed along the way as we discover more information about our moon. So far, it seems that whenever we think we get close to an answer, the newest data keeps throwing us another curveball, and we have to look at it again. We'll attempt to do just that by reviewing the available data, including the newest discoveries that we have to date. It's important to note that there are many things that make our moon unique. This applies not just to the physical makeup of our natural satellite, but also to the relationship that our moon has with its parent planet, Earth. These anomalies are important because they are key clues, the lingering fingerprints of a mystery that tells the story of our ancient past before life had its foothold on our planet. let's see if we can shine some light on these unique clues about our moon. Earth is the only planet in our solar system to have only one moon. While the large outer planets each have more moons than you can name, in the inner solar system, moons are very rare. Both Mercury and Venus have no moons at all, while Mars has 2 moons named Phobos and Deimos. They are thought to be captured objects because of their odd shapes and the close proximity of Mars to the asteroid belt. Our solitary moon is different not just because it is the only moon orbiting our planet, but that it is likely a piece of the planet itself. Which brings us to our next point. Our moon is made of the same material as the Earth. In contrast to most major element studies, recent isotopic data on lunar rocks presents a somewhat different story, namely one in which the Earth and Moon have isotopic compositions that are so similar that they are for nearly all measured elements virtually identical within laboratory analytical errors. The Moon has been drifting slowly away from Earth since its birth. The Moon drifts away at a rate of 3.8 centimeters per year. That's about 1.5 inches per year. Aside from the fact that our moon's soil is chemically identical to Earth's, this is an important clue that seems to support that the moon's material used to be part of the Earth itself at some point in prehistory. Our moon's near side and far side appear quite different. Earth's stronger gravity causes our moon to be tidally locked with our planet so that we only see one side of the moon, known as the near side. The near side of our moon is covered in the darker maria that we are all familiar with, but they are almost completely absent from the far side. Our moon has a slight egg shape to it, and the thickness of its crust does not appear to be completely uniform throughout the mantle. Most moons orbit their planet's equator, but our moon deviates about 5 degrees on either side of Earth's equatorial plane. This makes both solar and lunar eclipses on Earth rare, but easily predictable as we know when conditions are favorable. The Earth and Moon share an atmosphere called the Geocorona. First discovered in photographs taken of the Earth from the Moon during the Apollo 16 mission in 1972. The European Space Agency and NASA's Collaborative Solar and Heliospheric Observatory, SOHO, later confirmed in February of 2019 that there is indeed a geocorona that encompasses the entire system of the Earth and her moon in a thin atmosphere of hydrogen atoms, as it extends to over 630,000 kilometers above the Earth's surface. The moon's upper mantle seems to be porous. There is plenty of visual data to support this. The Lunar Reconnaissance Orbiter, or the LRO, also has some very detailed images of large cavernous lunar pits. The Selene mission also found some of these shafts leading to lava tubes thanks to some radar data from JAXA. These places are of interest to anyone looking to build on the moon because some are large enough to accommodate a substantial population while providing some natural protection from the harsh conditions on the surface. NASA's Grail mission used 2 satellites in orbit around the moon to map the gravity field. This revealed a porous landscape under the moon's surface that looked like lava tubes winding in and around the moon's mantle. The oldest lunar rocks have also shown the presence of a strong magnetic field signature during the moon's early history, which rivals that of the Earth's today, and which is now hardly present on today's moon. This suggests a very dynamic beginning for the moon, with a constant decline of its geological activity over time. Seismographic data shows that moonquakes reverberate for a long time, making it ring like a bell. The moon is still geologically active, which can pose a risk when setting up any permanent settlements for study, mining, or colonizing the moon. Recently, NASA has revealed that the moon is shrinking and causing many of these moonquakes. The moon contains much more water than we thought. We can no longer assume that the moon is dry. Not only did we discover ice in the shadowed craters of its poles, but most of the moon's water is actually locked up in volcanic glass and mineral deposits in the mantle. According to the latest research by Erik Hauri and his team, water would have had to arrive there in a window of time between the moon's moment of birth to no later than 200 million years after it was born. Otherwise, the moon's regolith would have been too solid to absorb it. In a recent study, rust was also found to be prevalent in the moon's mineral data, leading researchers to speculate the possibility of just how wet the moon actually used to be. The moon actually sounds hollow. It would be no surprise if the sensitive ears of the wolves, as their eyes are drawn to the full moon, could hear the sound of its whispering and moaning and cause them to howl in reply. beyond creating our moon, even more surprising to me is that this event also seems to be a key clue to the introduction of our abundant water, our dynamic core and atmosphere, and ultimately the growth of life here on Earth. Could a single event have created so many of the very essential things needed to achieve a balanced world that could harbor life? In the next episode, we will explore what happened to the Earth after the event that created our moon, and see if we can determine what effects it had on the mechanics and the development of our planet. Thank you for watching. Take care, everyone.